Today we'll have an interactive session. I'll solve a couple of questions based on transformer basics, and once I get to know the level and standard of these students who have joined this course, we'll accordingly scale up the level of problems. Okay, fine.
Fine, sir.
Okay. So should we start? Hello.
Yes, sir.
Okay. There is a question on the screen. If it is visible to you, please respond. Can you see a question on a magnetic circuit, basic magnetic circuits?
Yes, sir.
Yes, sir.
Okay. Please start attempting this question before I actually proceed with the solution. I'll give you 2 3 minutes, then I'll start solving. Okay. Are you? Let me introduce myself. I am Ashutosh Rai, pursuing PhD from IIT Mandi, and I'm a PMRF research scholar. So I will be dealing with your providing elementary knowledge about whatever is covered by whatever is covered in an electrical machine course, and week wise I'll try to map the questions for you. Everyone is comfortable in English?
Yes, sir.
Okay. So please go ahead with the question. The magnetic circuit, I'm dictating the question as well. The magnetic circuit given below has dimensions as follows. The cross section of the core is 4 cross 4 square centimeter. The mean flux path Lg is 0.06. Sorry, gap length, air gap, this is air gap provided here, was gap length is 0.06, and the mean flux path is 40 centimeter within the core, and then number of turns given is 600. You and the flux density, magnetic flux density established is 1.2 Tesla. Relative permittivity of core is 600 600 6000. And now you have to find what current is required to establish 1.2 Tesla magnetic field. Question is clear? Please respond.
Yes, sir.
So
Yes, sir.
should I start with the solution?
Yes.
Okay. Suppose this is n number of turns, and you know the relation mmf. What is mmf? Magnetic magnetomotive force is equals to flux into reluctance. Similar to, like, v is equals to ir. V is electromotive force in electrical circuits, and I is the current, and R is the resistance. Similarly, we have I mapping to flux, and R reluctance, RC, mapping to the resistance in the electric circuit. Clear?
Yes, sir.
Okay. So we have MMF given as number of turns into total current, and the current flowing in the wire, Ni, is equals to phi. Okay, it has given neglect fringing. What do you understand by neglect fringing? Suppose this is air gap. We assume that flux lines are passing under ideal condition. We imagine that total flux lines are passing from one cross section entering to the next cross section without jumping. Suppose if fringing is happening, fringing means some of the flux will pass like this, and another way the flux will go like this. It will not enter through this cross section. Clear? So it has given neglect fringing. That means the flux density which is inside this core will be same as the flux density which is inside the air gap. Clear? So we have flux into RC. What is RC? This is
Reluctance,
reluctance.
sir.
So reluctance, how will you find reluctance? This is L by mu A, where L is the length of the magnetic path divided by permittivity of the core or the air, whatever it is, and A is the cross sectional area through which the flux lines are passing. So we have got here, you can see this uh, reluctance of this core and the reluctance of air gap are in series. So, and just since we have neglected fringing, so we can say that RC core plus RG, this is air gap. Okay. Now,
Sir, RG.
yes, RG reluctance of the air gap.
Oh, yes.
Okay.
Yes, yes.
Okay. Then we have phi RC. For the core, we will denote it by LC upon mu naught, permittivity of air into relative permittivity of iron. You can see here it is given as 6000. Mu r of the core is given as 6000 into A. Since the air gap cross sectional area and the core cross sectional area are same, so I'll denote it by A, plus Lg upon, since mu naught is the permittivity of air, into A. Okay. And flux, you know, phi is equals to B into area.
Yes, sir.
Okay. So I will write this, Ni is equals to B into A, and I'll take mu naught A common from this. This will become Lc plus upon mu r plus Lg. Clear? So you can strike out this, and you have n given as 6000. I you have to find out. B is given as 1.2 Tesla. Mu naught is 4 pi into 10 to the power minus 7. LC is given as 40 centimeter. So since air gap is quite a small, 0.06 centimeter, I am considering entire length. I am not subtracting uh, 0.06 centimeter from LC. You can even subtract and do it. 40 into 10 to the power of minus 3, minus 2 upon 6000. Sorry, what is the number of turns?
Uh,
Number of turns is 600. Sorry. So
600.
we need to keep here 600 16,000 plus LG is 0.06. 0.06 into 10 to the power of minus 3. Please solve and you can get I value answers I have already provided. I will come as 1 point something, 1.06. Please solve and confirm that you are getting this answer.
Okay, sir. Within just 2 minutes, sir, I am
Yes.
confirming it.
I request others also to participate. If you have any queries, please let me know.
Hello, sir.
Yes.
Sir, this is first question
Yes.
today now.
Yes, yes.
Uh,
This is the question one. I'm starting with yes.
Okay, sir. Thank you.
Okay, okay, please. If you have any doubt, please let me know. I hope everyone who has joined is having elementary knowledge of these basic magnetic circuits.
Sir, please show sir question slide, sir.
Yes, yes, I'll show.
Okay, sir. Hold on a second.
Ayush, did you get the answer?
Yes, sir.
Is it matching with
G.
mine?
G.
Okay. So once you have got the
Sir,
current,
0.0106.
huh?
0.0106.
You are getting not
Yes, sir.
1.06.
0.0106. Yes, sir.
So please check out once if your calculations are right.
Okay, sir.
Meanwhile, let me check also.
600. Sir, 0.106 is coming right now, sir.
Uh, I think so. You are making somewhere mistake. I've just calculated. It should come around. Because you are having 4 pi into 10 to the minus 7 as denominator term, your answer
Yes.
cannot come in uh,
Yeah, yeah.
points. Okay, solve later on, and you may ask in the next section, in next session, if you have any doubt. So flux, next question is find the flux, corresponding flux and flux linkage. So flux is given as, what will be the value of flux?
MMF upon reluctance, sir.
Sir, we
Okay.
16 into 1.2, right?
Yes.
Yeah, right?
Yes, yes, sir.
So, sir, it's supposed to be 16 into 1.2, right? Like, I mean, the flux
16 into
into
1.2. Yes.
1.2. Ah,
Good.
yeah, yeah. But, yeah.
Sir, it was 0.06 into 10 to the power minus 2 for centimeter to meter conversion.
10 to power, if you 1 meter is equals to 100 centimeter. So if you map to the standard system, we need to keep all these in SI units. So it is given as centimeter, you convert it to meter, then it will be 0.06 into 10 to the power of minus 2 meters.
Actually, their written is 10 to the power minus 3. That's the mistake, sir.
Where?
Here the 10 to the
Okay.
power
Oh,
minus 3.
oh, oh. Thanks. Thanks a lot. Okay. So flux will be 1.2 divided by the cross section area. What is this? 4 cross 4, that is 16, into 10 to the power of minus 4. Flux B into A, that is 1.2 into 4.4 into 10 to the power of minus 4. And as someone pointed out right now, it will be like 19 into 19.2 into 10 power minus 4. Is everyone getting?
Yes, sir.
1.2 into 16 into 10 power minus 4. And as far as this is, flux has units got Weber. And flux linkage is denoted by lambda, and it is n into phi, where n is your number of turns, that is 600 into 5. That will be something around 1.1 1.152 Weber turns. Is it clear to everyone? So that we may proceed to next question. Please respond.
Yes, sir. Cleared, sir.
Yes,
Okay.
sir.
Is it same for everyone? Should I proceed to the next question?
Yes, yes, sir.
Yes,
Okay.
sir.
Sir,
Yes.
sir, could you show the answer for the flux linkage in the previous question?
Okay. This is answer is 1.152 Weber turns.
1.152. Sir, so like lambda is n5, so
Yes.
600 multiplied by 5, right? Like 600 into.
600 into flux, 19.2 into 10 power minus 4.
Okay, okay, fine, fine.
Okay.
Yeah.
Is it clear? You may note down the answers. This is 1.06 ampere for the excitation current, 19.2 into 10 power minus 4 Weber for the flux, and flux linkage is 1.152 Weber turns. So this is the next question. We'll start with this transformers basic question. It is two, two, three, 2300 by 115 volt, 60 hertz, 4.6 kVA step down transformer is designed to have an induced EMF of 2.5 volt per turn. Assuming an ideal transformer, calculate number of high side and low side turns, rated primary and secondary currents, step down and step up transformation ratios using the above two. So it is very elementary and basic question. So we'll see. I think you must be aware of the basic EMF equation of a transformer. What is that? That is
E
4.44
बराबर 4.44 F 5 and
NP, number of turns or okay. This is the basic EMF equation. This gives us the RMS RMS voltage value. Okay, so in the question it is given as that a 2300 by 115 volt 60 hertz 4.6 kVA step down transformer is designed to have induced EMF of 2.5 volt per turn. So since we have to calculate number of high side and low side turns, this is high side and this is low side. So EMF per turn is given to you. EMF per turn is 2.5 volt per turn. So to get 2300 volt at the high side, how many number of turns is required? This is basic unitary method question now. So you can say divide by number of EMF per turn is 2.5 volt. So that will come out to be something 920 turns. Now if you go for the low side terms, it will become 115 divided by 2.5. That will give you number of high side turns. That will be around 46. Clear?
Yes, sir.
Okay. Now it is given rated primary and secondary currents. We have been given a rated. What do you understand by what is the meaning of rated? Rated value means transformer has some nameplate details.
Sir, high voltage side 2 ampere
Hmm. Okay, and
and the low voltage side 40 ampere.
yes, right. So rated values, rated nameplate details are the rated values of the transformer. That means when you will apply 2300 volt at the as the rated voltage, it will be able to deliver 4.6 kVA apparent power. So apparent power S is given as V into A I. So from there you can find out. Okay, what about the transformer ratios? Ref
Yes,
from
sir.
low voltage side to high
20,
voltage.
20, sir.
Oh,
Transformation ratio.
that means step up ratio and step down ratio both you can find out. That is inverse to each other.
Yes, sir. 20, sir.
Okay. And if someone asks you what is the step down voltage, then it will be 0.05.
Yes.
Clear?
Yes, sir.
Should I
Yes.
proceed to the next question?
Yes, sir.
Yes, sir.
Okay. Thank you.
Sir,
Yes.
sir, this session will be available for us
Yes. Yes.
further, sir,
Yes.
after
Yes. It
this.
will be available. I
At,
will provide.
at which platform, sir?
Uh, people will PMRF people will provide. Sorry, NPTEL people will provide you.
Okay, thank you, sir.
Yes. This is the next question. This is a 1 kVA 220 by 110 volt 400 hertz transformer is designed to be used at frequency of 60 hertz. Calculate the maximum RMS value of voltage that may be applied to the high voltage side and maximum voltage output of the low voltage side. Also, the kVA rating of the transformer under conditions of reduced frequency. Please start attempting. I'll give you 2 to 3 minutes before I actually provide you with the solution.
Sir, please scroll down, sir. Okay, okay, thank you, sir.
So I think I should start providing the solution. So you are given a one.
33 volts, sir.
Yes, very good.
And one is 1 point, sorry, 16.5 volt.
Okay. What would be the kVA rating now? Since we have got that it is a maximum value or that may be applied to the high voltage side, and initially the transformer was designed for 400 hertz. Now we are downscaling the operating frequency to 60 hertz. You know that induced EMF E is somewhere
Frequency.
function of frequency. So when you had 200 when you had 220 volt, it was operating at 400 hertz. Now when you have got 60 hertz, it should be 220 into 60 divided by 400. That means around 33 volt. Okay. Similarly, for the secondary side, you will be having 110 into 60 divided by 400. That gives you 16.5 volt. And similarly, with KVA rating is V into I. So somewhere this is function of frequency. So KVA rating will also be downgraded, and it will come like when it was 1000 VA, it was operating at 400 hertz. And now it is operating at 60 hertz. So what will be the VA? That will be 1000 into 60 divided by 400. Are everyone clear with it?
Sir, for KVA rate calculation of KVA rating, please
Oh,
repeat it, sir.
okay. I said that KVA is apparent power S.
Yes,
Apparent
sir.
power S is V into I conjugate. Now, in simple terms, try to understand S is equals to V into I. When magnitude is, because this is given in form of magnitude, no, it is not said. So you can write V into I, and so this will be V is function of, can I, V is
Ah,
F. So,
yes, sir.
so if voltage is, if it was 1000 at 400,
Okay.
sorry,
Yes, sir. Thousands is mentioned in the question, sir.
1 kVA is given na initial.
Yes, sir. Yes, sir.
So it will be downscaled to 1000 into 60, because V is function of frequency. So we have already calculated that value. Clear? So should I move to the next question?
Yes, sir.
Sir,
Yes.
sir, why मतलब why S बराबर VI conjugate, sir?
Why S is equals to V I conjugate. This is a power systems part. Let me explain you how we get. Suppose this is are you people familiar with phasors?
Yes, sir.
Okay. Then let's say this is an inductor. So we are applying some voltage here. Okay. And this is the I current going. You know that, let's say we are assuming this as the base phasor V. So current will lag by
90
90,
degree.
90 degree. Clear? So if I say what is the instantaneous power, what will you say?
Yes, sir. Both voltage into current only.
Suppose P into T will be Vt into It. Okay. So when you take power, suppose you have taken the magnitude, you can in terms of phasors, you will multiply v into I. So yeah, wait a minute. Actually, we need to get the angle between V and I.
Yes, sir. Let us phi.
Huh? So that is 90 degree. So if I take conjugate, do you let me
Hello, sir.
yes,
Oh.
Sir, the recording will be available, right?
yes.
Okay, sir.
Sir, where recording is are available?
The recording will be given to you by the team. They will make you available.
On a NPTEL website?
Yes, yes.
Okay.
Sir, it will be mailed to us, or will it be available in the NPTEL website,
Uh,
like in the Swayam portal?
I'm not very clear about it. I'll ask. This is the first lecture. I'm not knowing much about these things, so I'll
Okay.
verify. But the team has told that they will provide you with these solutions and the recordings and everything.
Okay, sir.
Okay.
In previous lecture, sir, you were not there, sir.
So I am Ashutosh, and recently I have started. I have joined NPTL for this TA-ship work. So this is my first lecture, and every week Tuesday I'll be taking for you. And
Okay.
actually,
But
please let me know the level so that I can scale up the level of questions. This is the first class, so I am dealing with very elementary and basic questions.
okay, sir. That means in a week there will be a two sessions, sir, for practice session.
Yes. This way this will
Because
enhance the learning someone else might have taken in last week to for you people with a different set of questions. So
yes, sir. It
uh,
will definitely will
huh.
it, sir, help us in the final exam, sir?
Yes, yes.
Okay, thank you, sir.
From next session onwards, I'll procure the set of questions from available in your assignments. And since I was not able to access the assignments, I'm not able to deliver these questions as per your assignment. From next session onwards, you will have these assignments. Okay.
Okay,
So
sir. Okay.
someone was asking about the conjugate. See, now when I will multiply v theta into I angle theta minus phi and take the conjugate of it, then we will get v angle theta dot conjugate means angle, this will turn phi minus theta. Okay, when we take conjugate, so then it will become vi, and you know, in phasors angles will be added, that will be phi minus theta, sorry, theta minus theta plus phi minus theta. So theta and theta will go away and you will get vi angle phi. This is the phasor representation of the power. So you have p is equals to vi angle phi. Clear?
Yes, sir.
So see, with any arbitrary phasor, we are able to get uh, power as Vi angle phi. And when you decompose this, you know, this can be written in the form of cos theta
And plus J
plus
sin
j
theta.
sine phi. So when you will multiply Vi cos phi, this will become your real power, and
The
Vi,
imaginary power.
this will become your
Imaginary.
Reactive power.
reactive power. And when this is real, this is reactive, and when
Both
we
are complex power, which is
so
also known as apparent power, sir.
yes, total s we will get, this is called as apparent power. Let me write it clearly.
Instead of P, there should be S, sir.
Wait.
Yeah, yeah.
I'm
Below
not,
P, we
yes,
should write S.
yes, s is apparent power. So s is equals to vi cos phi, so accordingly it will become vi cos phi plus j vi sin phi. This is your apparent power. This is your real, and this is your reactive. You might, the transformer has, if I ask why transformer is rated in terms of apparent power, can you tell me, any one of you? You might have seen in earlier questions,
Yes.
everywhere
Yes,
it is
sir.
written kVA, not kilowatt.
Yes, sir. I can tell.
Yes,
Because
Uh,
sir, cos phi is absent.
yes,
Because sir, cos phi is absent due to the sum. All losses are in the form of voltage and current. That is mean iron loss, copper loss
yes,
is in the form of voltage and current. So
okay.
power factor is absence. So rating of transformer is in the form of kV.
Anyone else? Okay, you're right. Anyone else? Because there can be n number of explanations for it.
yes, sir. Because uh, there is a sir protection of winding is depends upon only voltage and current, sir. Uh, like if sir voltage winding, sorry, winding specification is depend upon only voltage and currents. That's why we use only V and I.
Okay, actually, one more possible explanation from my end is like, we do not know the nature of load which will be connected to it, whether it is supply, whether it is absorbing pure power, reactive power, or anything. Clear?
Sir, tell me, sir, exact.
Exact. I'm telling you that since we do not, one is the, just now a student amongst you provided the answer that we have all these iron loss, copper loss, and all these things. That is also somewhat right answer, but the correct answer, we do not know the nature of load it is going to supply. Okay, whether we are going to have a resistive load, whether we are going to have an inductive load, or it will be capacitive, or combination of resistive and capacitive, or anything. We do not know the nature of load. It is, transformer is a static device which is only used to step down and step up or step down the intermediate voltage levels. Okay,
Yes, sir.
so it has to supply both active and reactive power depending upon the nature of load. Okay,
Yes, sir.
so next question. Hmm. Are you able to read this question?
Yes, sir.
Two. Okay, let me please wait. Before we attempt this question, we have another question linked to that previous. Hmm. Question is, assuming both eddy current and hysteresis losses vary as square of flux density, calculate the iron losses if transformer of previous question is operated at rated voltage but at frequency of 60 hertz. Assume original iron loss of the transformer is 400 hertz. At 400 hertz is 10 watt. अरे अरे सर प्लीज थोड़ी स्केल कर दी आवाज भुन 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 आप सुनाई दे रही है आपको बोले थे कि मत आइएगा आप लोग so are you able to see this question is now at 400 hertz you had the iron losses of 10 watt. Now your operating frequency is 60 hertz. What will be the iron losses under this condition? Earlier when we were operating at 400 hertz we had iron loss of 10 watt. Now we are operating at 60 hertz. What will be the loss? But the condition is you are operating at the same rated voltage, not voltage which you have found out in this question. You are operating at 220 oblique 110 volts only. Voltage ratings are same, but the operating frequency has been changed to 60 hertz. And it is mentioned that uh, losses are proportional to square of the flux density. So please attempt. Are you able to get the question? It is given that we have iron loss is equals to hysteresis loss plus P eddy current loss. But it has given assuming both eddy current and hysteresis loss vary as square of flux density. So let us assume that overall iron loss, as per the question, iron loss is proportional to square of flux density. Okay, it is given that Pi at 400 hertz is equals to 10 watt and flux will be proportional to V by F. Flux will be proportional to V by F. How? See, you have got E is equals to 4.4 44 F phi N. Okay, so since we are not changing this value, neither we are changing the number of turns, we are changing only the frequency. So the operating flux, if we neglect the resistance and leakage inductance, you can say that flux is anyway proportional to E by F. This is K, something constant, and you can directly write this as V by F. If we neglect the losses, then you can write it is proportional to V by F. So now what will happen? It is given that we are operating at the rated voltage, we are not changing the voltage, so flux will be proportional to 1 by F. And also, since iron loss Pi is proportional to phi square, it will be proportional to 1 by F square. Clear to everyone?
Yes, sir.
Okay. So when
Yes,
frequency,
sir.
when power iron loss was 10 watt, it was proportional. Sorry, we can write as Pi Fi square is equal. Sorry, P iron 1 into F1 square is constant. So we can write Pi1 into F1 square is equals to Pi2 into F2 square. Okay. So we have to find out at 60 hertz. What will you do now? Simple. This is 10 watt into 400 hertz square upon 60 hertz square, that will give you Pi2. Okay, is it clear? Please respond. What is the value?
4.44, sir.
4.44 or 4
Sorry.
44?
444.44.
Okay,
444.44. Yes, sir.
okay, क्लियर? समझ में आ रहा है सभी को?
Yes, sir.
Okay,
समझ में आ रहा है.
so we will move with the next question now. इससे पहले एक और क्वेश्चन आयरन लॉस और इस पे कराते हैं. हम्म. In a transformer, the core loss is 100 watt. What do you mean by core loss? Core loss is core loss and nothing say same as the iron loss, which comprises both of the. That is equals to eddy loss plus hysteresis loss. Okay, what it is given that iron loss, iron loss at 40 hertz is 100 watt. and at 30 hertz it is 72 watt. Now eddy loss is proportional to frequency square, operating flux density square, and here hysteresis loss is proportional to frequency into b to the power of estimates constant. Okay, so since operating flux density in a transformer is constant, we will say that will this eddy loss Pe is some constant Ke into F square. What we are varying, only we are varying the frequency, not the operating flux density. So this is P H hysteresis is Kh into F. Okay. So can I write Pi as Ke F square plus KHF? Yes or no? Please respond.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So when frequency is 40 hertz, we have 100 watt is equals to Ke 40 square plus Kh 40. Similarly, at 40. Now, when it is 30, it is 72 watt. 72 watt Ke 30 square plus Kh into 30 at 30 hertz. So you have these two equations, 1 and 2. So first solve these equations to find value of the constant Ke and Kh. Please solve. What are you getting value of Ke and Kh? These are simple ordinary equations, linear equations in two variable.
Ke is equal to 0.01
K
is equal to 0.01.
0.01. Someone else?
Please, sir, show me equation. Okay, okay. Thank you, sir.
KH equals to 2.1.
Kh is
2.1.
2.1. What about KE? Is it matching with this guy?
Yes, sir. KH is equal to 2.1.
Okay.
I'm matching with her.
Okay. Now, simply it has in the question you have been asked, find in transformer core loss is 100 watt at this frequency and 72 watt at 30 hertz. So then find eddy current and hysteresis loss at 50 hertz. So eddy current loss will be P eddy is equals to K eddy into 50 hertz
F.
chi square, and P hysteresis will be equal to KH into 50. That means it is 50 square into 0.01, that is 25, and 2.1 into 50, that is 105. Clear? Is everyone able to get? Hello?
Yes, sir.
Should we proceed to the next question?
Yes, sir. Carry on, sir. Is means
I want other people also to participate so that I may be able to know the nature of the participants with respect to the knowledge of machines. This is again a simple question. Uh, a 2300 oblique 230 volt 500 kVA 60 hertz step down transformer has following values: R1 as 0.1 ohm, X1 as 0.3 ohm, R2 as 0.001, and X2 as 0.003 ohm. When transformer is used as a step down transformer and loaded to its capacity, calculate secondary and primary currents. I hope you are familiar with the equivalent circuit of transformer. We have this as R1, the leakage inductance X1, then we have core loss component RC, then we have the magnetizing branch X5 or XM, whatever you say, then we have R2, this is JX2, and this is V2. When I have said that this is the transformer circuit, I say if suppose this is high voltage side and this is low voltage side, V2 dash is equals to AV2, R2 dash is equals to A square into R2, and X2 dash is A square into X2, where A is turn ratio. So this is equivalent circuit
Sir,
refer
go
to.
with its explanation, sir.
Yes.
Please, sir. Please go with explanation of this transferred impedance. As you write, R2 dash is equal to A square into
Yes,
R2.
yes,
Please.
yes, yes. Equivalent circuit referred to, let me complete. Equivalent circuit referred to high voltage side. This is, you derive, this is the basic transformer circuit. Okay. This is like we are assuming that there is a tight coupling. This is the induced EMF E1. This is induced EMF E2 in the two windings. Like this is E1. This is E2. This is V1. This is V2. Clear? This is a, try to understand this. Now, what we do, we want that this, how to represent this through an equivalent electrical circuit. How will you do? We need to transfer that, there is no connectivity between these two circuits. Okay, there's no connectivity. How will you merge them together?
Using transformation ratio, sir.
Yes, exactly. What is that? We have V1 by V2. Sorry, very specifically, we have E1 by E2 is equals to N1 by N2. Okay. Similarly, I1 by I2 is equals to N2 by N1.
Yes, sir.
Okay. When I used A here, I meant N1 by N2. As per the standards, we generally consider A as N high voltage side upon N low voltage side. This is standard from IEEE. So we have E1 by E2 is equals to N1 by N2, and because you may have seen people representing that transformation ratio, low voltage transformation ratio, high voltage transformation ratio and all, but the exact standardized, whenever someone has given you A or N or something transformation ratio, it will be number of high voltage turns upon number of low voltage turns. Okay. Now we want that we need to have a connectivity between this
Sir,
circuit. We need to replace this part. Okay. How will you do?
sir, please tell me again, sir. There is slightly voice problem, sir.
Okay.
Okay, okay. Okay, right now, okay, sir. All are fine.
You are
Tell
able
me,
to
sir,
hear.
again, sir, please.
Okay. You
What
write
you have asked me, sir?
E2. Go to this secondary part E2. How will you write E2? E2 you will write I2 R2 plus JX2 I2. These all are phasors,
Plus V2.
plus V2. Okay.
Yes, sir.
What about V1? V1 is the
Uh,
source.
I1 into R1 plus Jx1 into I1 plus E1.
Can we write E1 as, let this be represented as A? Huh? Turn ratio
Mm.
N1 by N2, we are saying this is equal to A. So E1 by E2 is equals to A. So can you write E1 as AE2?
Yes, sir.
So V1 will become I1 R1 plus J X1 I1 plus AE2.
Yes, sir. Right.
Hmm.
Absolutely.
So let me create a space. In this equation, this this equation, uh, if I multiply A on both side, hmm, this I can add this part here.
Yes, sir.
This will become V1 is equals to I1 R1 plus J X1 I1 plus A I2 plus J A X2 I2 plus AV2, right? Hmm. Clear or
Yes, sir.
not? Now just
Yes, sir.
you know that I1 is equals to I some more basic parts you need to know that what we call, let's say, N1 I1 is the primary MMF established minus N2 I2 is equals to
Equal to 0.
0. Okay na? Due to which you get this, if you are ignoring the magnetizing current or no load current I naught. Hmm?
Sir,
Yes, sir.
Yes.
sir, these equations is compared with the KVL equation in an electric circuit, analogous to KVL equations like
Yes, yes.
magnetic circuit,
We can
MMF balance
compare.
principle.
We can compare.
Okay, okay.
So let me
Yes, sir.
proceed.
This
This
one
is
is the MMF
this
balancing
yes.
equation.
This is MMF balance on no load. Sorry,
Yes.
MMF balance on load where I am neglecting this magnetizing current. I am saying that my current is zero. Else, if you consider the no load current, you will write the MMF
Yes, sir.
balance equation as,
That means highly permeable magnetic core.
yes, yes,
Therefore,
yes,
sir.
yes, correct. So let me complete this. J I1 X1 plus A I2. I think we have made mistake. A I2 R2. So plus J A X2 I2 plus A V2. I will make some small modifications. Multiply by A and divide by A here. Okay. So you will write I1 R1 plus J I1 X1 plus I2 by A into a square r2, a square r2. This I will represent as r2 dash later on, plus j I2 by a into a square x2 plus av2. So if you will see from now this equation, if we write, go with kvl here, this is, here is I1, here is I2 dash, then you will, and if you represent r2 dash by a square r2 and x2 dash by a square x2, you will land up with this equation: v1 is equals to I1 r1, I1 r1 plus j I1 x1 plus this is I2 by a, that is represented by I2 dash, a square r, that a square r2 is represented by r2 dash, and this is represented by
J
I2 dash,
into
j I2 dash x2 x2 dash plus av2. समझ में आ गया?
it is,
Is it clear how I am writing this?
yes sir, it is totally referred to primary side.
Primary side. Now we were, once again we will proceed with the circuit. This is r1 r1 jx1 this is r2 dash jx2 dash and av2. This is v1, this is rc, this is xy. We have lot of questions, we need to proceed fast. Okay, so
Yes sir.
this is our question, main question. Oh, what happened? Why is the question not coming? Okay, the question is in front of you. When transformer is used as a step down transformer and loaded to its capacity, calculate secondary and primary currents. Loaded to its capacity means 500 kVA, it is delivering 500 kVA. That means,
That's rated impedance. There should be, sir.
yes,
Capacity. What do you mean by this statement, sir? Like transformer and loaded to its capacity.
yes.
What?
When
What?
the transformer is used as a step down transformer and loaded to its capacity means, when we will connect this transformer, loaded to its capacity means at output it will give 500 kVA at the rated out secondary voltage. Rated secondary voltage is 230 volt. That means my transformer will, when I will connect a load here, any load I will connect, and if I maintain 230 volt here, that load will be capable to absorb 500 kVA of power. That means the transformer is loaded to its capacity. Clear?
Yes, sir. Thank you very much, sir.
Whenever it is, whenever someone asks about the rated value, that means at rated rated values, whatever is the nameplate detail, the rated power should be delivered at the rated voltage. If machine is 500 kVA, it has to give at that specified 230 volt, it has to give 500 kVA. Clear? So
Yes.
what is the question? uh, Secondary and primary current, what will be the value of secondary and primary current? Is will be equal to Va kVA upon Vs. That is kVA is 500 into 10 to the power of 3 upon Vs is 230. Please solve and get it. Similarly, I primary will be 500 into 10 power 3 upon, I think so, secondary voltage is 2300. Fine. So this is coming out to be, this value is 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 217.4, 217 3 point something like that it will come. And it,
2173.913, sir.
okay, and similarly here it will be 10 times less because transformation ratio is 2300 by 230. Here secondary side it will draw have more current. I secondary, you can see it is 2173, and here it is 217.
217.391, sir.
Okay. So next part, it is given secondary and primary internal impedances. Secondary and sorry, secondary and primary internal impedances. How will you find secondary and primary internal impedances? It is given that value of R1 is 0.1, JX1 is 0.3, this is R2 dash is 0.001, and this is 0.003. You can see
Sir, total impedance is 0.316, sir. Ohm.
this will be just what you have to see, that Z primary will be R1
R
plus
plus JX.
JX1, and Z secondary will be R2 plus JX2, and then you need to take out the magnitude, that Zp will be equal to under root of R1 square plus X1 square. Similarly, Zs will be R2 square plus X2 square. You can your answer is right, 0.316 at the primary, and at the secondary 0.00316.
Yes, sir. Sir, I want to ask some questions, sir.
Yes,
In final exams, we are permissible to carry a scientific calculator, sir.
yes.
Yeah, there will be virtual calculator on the desktop,
uh,
like GATE exam.
I don't know actually.
The virtual calculator are available on a desktop mode.
To be very honest, I think so. It will be in available at the online platform only, and it is simple to operate. Try to have practice, download scientific calculator and like that in net, and try to practice. And don't worry about exams right now. Please try to go with the course.
Okay, thank you, sir.
Hmm. These are, try to understand. Later on, we'll deal with all these things. Okay.
Yes,
So
sir. Thank you, sir.
next part is secondary and primary induced voltages. Secondary and primary induced voltages. How will you find?
Yes, sir. Using KVL equation.
Some drops are
Yes,
minus
yes,
with the supply
yes,
voltage.
yes, yes, yes. E1 will be
V minus
V1 minus ZP.
ZP IP.
Yes, it is given na, that
Yes,
assuming
sir.
that it is written here, assuming that terminal and induced voltages are in phase. So you can simply, like you have na, this is flux, let's say this is flux, then you have
Induced voltage EMF, supply voltage,
supplied voltage V1. So
and
suppose this is your, this is
magnetizing
I
current,
naught, and
noted current.
reflected current from the secondary is like this,
Yes, sir. I2
I2
dash.
dash, then summation of these two
Result-
becomes
Resultant current I1,
hmm,
IP.
like this, it will be some I1 will be the current. So
Yes, sir.
it is given that at the end your E1 is lying somewhere after phasor sum, E1 is lying here on this only, that this is the conclusion. You will write,
Yes,
suppose this is I1 line, then we will have some, suppose this is I1 at the end, for phasor calculation. This will be I1 R1, will proceed with some I1 R1 is the drop like this. Then my JIXP is happening, so that this is E1,
both are in phase, sir.
and this is V1. Okay. So proceed with the question.
Sir, there is a inductance, no, sir. Then how
Yes.
is it possible, sir, that there is a same phase difference between both, sir, like V1 and E1?
Under just it is like it is, that's why it is given assumption, just for,
Okay.
because we have not given the no load power factor na, we have not
Yes.
provided any no load power factor, or power factor things are not provided, so you cannot calculate otherwise.
Okay, sir. Okay. Thank you, sir.
So
Mm.
simply you need to subtract, since it is given that they are in phase. So E1 is equals to V1 minus ZPIP. Similarly, E2 will be equal to V2
Yes, sir.
minus,
Using a simple KVL equation.
yes, yes. Similar, so next part is, similarly we will, there are so many parts, ratio of primary to secondary induced voltage. Primary to secondary induced voltage is, let's say we have got primary induced voltage is 68.8, and 6 secondary induced voltage is 6.88, so you will divide and get the value. Okay.
Yes, sir.
And when it is talked in terms of terminal voltages are 2300 and 230. Okay.
Yes, sir.
Okay. So do
Then,
you,
you, sir, during during the calculation time of the transformation ratio, sir,
yes,
which
uh,
we have to prefer, sir, terminal voltage or induced voltage,
see, when
ideally.
in question, if nothing is given, you need to go with the terminal voltage, the rated values,
Okay, sir.
until unless it is specified in terms of induced voltages.
Okay, sir. Means by default you have to follow first approach, like you have to go through the terminal voltage which is mentioned in the rating plate.
Yes,
And one more doubt, sir. There
yes.
is, I want to just ask that, sir, if there will be contradiction, or there will be such a situation that we have to calculate the transformation ratio. Okay,
Hmm.
just simple a step down transformer.
Yes.
That is, there is a simple step down transformer, sir. Then how to calculate using N1 upon N2 or NHV upon NLV. HV
See,
means high volt.
until and unless it is specified, until unless it is specified, you need to go with NHV by NLV. If if the examiner is having some other perception, if he is having, he will always mention,
Like, sir?
and he will mention in terms of it will be written in the question that turns ratio of high voltage to low voltage to high
Okay.
voltage. Huh?
Yes, sir.
Okay. Now we'll
By
go.
default, we have to follow a
Tra-
number of turns at HV side and
uh,
upon number of turns at LV
LV
side.
side, yes.
Okay, okay. Thank you,
Now we
sir.
will go with some open circuit, short circuit test questions. Proceed fast. You know na open circuit OC test.
Yes, sir.
So question is, with instruments connected at low voltage side, you know, when we perform open circuit test, we keep the measuring instrument on low voltage side, so that low rating instruments can be used to measure the current and voltages and the power. So it is given in the question that POC is 80 watt, I naught no load current is 4.2 ampere, and no load voltage at the I mean, we perform the open circuit test under rated voltage condition. Rated voltage condition. Okay, we perform
Yes, sir.
no load test under rated voltage conditions. POC I naught, then we have VOC
VOC
as 120 volt.
120 volt.
What we will do, when we see the open circuit test, what we generally do, we neglect the resistive, so we neglect the impedance of the primary. You can see the circuit this side I had just shown na, we have high voltage as open, we are not connecting at any load here, no load, and at low voltage side we are applying 120 volt, so that it is drawing 4.2 ampere current and power of 80 watt. So this is RC and this is X5 or XM, whatever you say. This we have to find out. These are the no load parameters which we need to find out. So how to find out what will be value of RC in a parallel
Also,
circuit? In a parallel
voltage
circuit,
are same.
huh?
Voltage are same, sir.
So voltage is 120 only. So you can easily find out what will be the value of RC. Power is given. Power POC will be V naught I naught cos phi naught, like that. Huh? Under this
Yes.
condition, how will be the transformer will be supplying only the magnetizing part of the current, that is I naught, that will be broken into IC and, sorry, this will be
IM.
IC and this will be IM or I5, whatever you call with respect to. This is the magnetizing part, this is the core loss component. Okay.
Yes, sir.
Tell what we, please try to calculate what will be the value of RC from here. Also we can write na, that RC is equals to VO, sorry,
V naught a square upon R.
yes, V naught OC square upon
R
POC.
into cos phi. Yes, sir. Yes.
Please tell me the value of R. Oh,
V naught. 180, sir. Ohm.
180 ohm. Okay, let others also solve.
Sir, cos phi.
Anyone else?
Cos phi का value कुछ दी. Is there the value of cos phi not, sir?
Hmm. If you can find out na cos phi naught from here also.
अच्छा. Yes.
In a parallel circuit, if I ask you what like how this it is a parallel RC circuit. Sorry, RL circuit, parallel RL circuit. Huh?
Yes, sir.
So phi can be given as tan inverse R by X. As in a series circuit RL, we have phi is equals to tan inverse X by R. In a parallel circuit, if you will solve, you will get phi is equals to tan inverse R by X. So once you get cos phi naught from here, that is 180 divided by 120 into 4.2, you will get cos phi naught. Okay, so from here you can get value of phi, that will be
0.148.
huh? Please.
80 degrees, sir. 80.86.
81.48.
Phi is get shift
80.86.
80.86. Fine. So what did you get value of R? 180 ohm. So
Yes,
what
sir.
will be value of X? XC or XM, whatever you call, that will be sorry. I told you in a parallel circuit phi you will write as tan inverse R by X. So you get X is equals to R by,
And phi.
tell me what you are getting value of X.
And, sir, there is 28.96. Sorry, ohm.
Hmm?
28.96.
Cos 50 tan 80.86 inverse into 180. 28 point.
96.
So if you read in the question, they have given that these values you are getting from referred to LV side. But in the question it find the resistance and reactance of the equivalent exciting circuit referred to high voltage side. What you will do? Refer to high voltage.
Just we will divided by a square, sir.
Huh. This is
Then
RC
please
value
show
is
me again
180
question,
ohm.
sir. I want to know transformation ratio.
Okay, I'll wait for a second. This is 28.96. Remember one thing, that at the low voltage side, these referred values will be low. Anyway, referred values will be low. When someone has asked to the refer to high voltage side, you need to multiply with A square, that is NHV by NLV. Sorry, that is nothing but in this question it is 450 by 120. NHV A is equals to NHV by NLV, that is 420 by, sorry, 450 by 120. So what will you get? A is equals to 450 divided by 120. This is
0.75.
3.75 something. So referred to high voltage side, your
2.53
RCHV
kilo
will
ohms,
be
sir.
equal to 180 into A square, and X5HV will be given as 28.96 into A square. What are you getting?
Sir, RCHV is equal to 180, sorry, 2.531 kilo ohm.
Yes, that is 2.531 kilo ohm, and this is
This one is 0.47,
uh,
0.4 kilo ohm.
0.407 kilo ohm.
Kilo ohm.
Okay, fine. So let me go with the next question, that is based on short circuit test. Hmm? So how do we perform a short circuit test?
Sir, in short circuit test, we short circuited the terminal at low voltage side, sir.
Yes, exactly. What we will
And
do?
we connect the all reading meters at the high voltage side.
Yes. So we will do it by, we connect the terminals.
Sorted.
Low voltage side is short circuited. Okay. Now, but this is not done at the rated voltage.
No, sir. Yes, sir. Yes.
Generally, to drive, we need to get the full load current. We get full load current. I forgot to tell you one thing here. It is performed under rated voltage and rated frequency condition. Here, what is the objective? Objective is to find out iron losses. We get for a short circuit, for a short circuit test, we get the copper losses. So for to get the copper losses, we need to circulate the rated current in the circuit. So it has been seen that if you will apply just 5% to 10% of this rated voltage, you will get rated current. So since we are not operating at rated voltage, this iron losses are insignificant. This would be significant at, since we are just at operating at 5% of this rated voltage conditions. So we can ignore this iron loss because these are proportional to voltage, so we can ignore this part. So what will you do? Ignore this.
Sir, repeat again, please, sir.
In short circuit test, we apply around 5 to 10% of rated voltage. That is sufficient to circulate the rated current. Okay.
Okay, sir. Okay,
And
sir.
since this shunt branch, which consists of the RC and X5, the losses in these are proportional to voltage, not to current. And the voltage which we are providing at the input terminal is very small, so we neglect that. We assume that whatever we are conducting in the short circuit test, the power loss is going purely as copper loss.
Yes, sir.
Okay.
Okay, thank you, sir.
Okay. So this is uh, question, what are the values? This is, you can see this transformer was in this question, question number 6. This question, see, transformer voltage is 2400, but we are operating at 48 volt only. Tell me what is the percentage. 48 divided by 2400. See, it is, you are getting as 2% of the rated voltage you are able to circulate the rated current. That's why we are neglecting the
Shunt
iron
parameters.
losses. Huh?
Just yes, sir.
Okay. So note down these values. This is 48 volt, 20 ampere, 20.8 and 617 watt loss is happening. So if we club together, let's say this, since we cannot segregate here, which is primary side, which is secondary side, we'll write as R equivalent, X equivalent. And this is 48 volt, current is 20.8, and this is short circuit. So this is simple Z equivalent. What you will say? Z equivalent is equals to 48 by 20.8. This is mod Z equivalent. So also you can write now that P short circuit is equals to V short circuit I short circuit into cos phi. I told you. So we, you have PSC, VSC, ISC, Z equivalent, cos phi, Z equivalent value, what will get? What will you get? 48 divided by 20.8. That is 2.30
Yes.
ohm. And from here cos phi value will get,
X tan inverse. Sorry.
you can, here we have tan phi as X by
Yes.
R.
X
This is
by R.
series resistance. So from here,
Cos of tan inverse X upon R.
yes, yes. So cos phi, tell me what is the value.
Uh, what is the value, sir? I want value of X and R.
Then fine. I'm not asking this. First, try to calculate what is cos phi. Cos
Okay,
phi
okay.
will be.
Sorry, sir.
Arey, no
PSC
problem.
upon VSC into ISC.
Yes.
Then how much was there
Six
PSC,
one
sir?
hundred seven. Say 16 617.
670 17. Okay. Upon VSC 48 into. Sir, there is 617. Yeah, 670, sir.
617. Please
Okay,
note
okay.
down the
Then
question first.
0.617, sir.
Hmm. 0.617. Okay.
Yes, sir. Value of cos phi.
Hmm. So R you can write as Z equivalent cos phi. 2.3 into 0.617, that is equals to 1.4191 almost. Similarly, X will be Z equivalent sin phi 2.3 shift sin cos.
into cos inverse, मतलब sin into cos inverse 0.617.
Tell me the final answer. Are you getting 1.81 ohm? Please, what about others? Only this guy Ayush is interacting. I request others also to participate.
Hello, sir.
Yes.
Sir, this session's PDF will be available.
Yes.
Sir, to where, which place I should download this PDF, sir?
Do not worry, everything will be communicated from NPTEL.
Sir, there is a 1.5663 ohm for the value of x, sir.
No, it is wrong. You have calculated somewhere wrong. This is cos phi is 0.617. Then sin phi will be other way 1 minus cos square phi. Under root of 1 minus cos square phi, like that. You can also go, or just if you are having scientific calculator, you can do by simply sin cos.
Okay, sir. Sorry.
Value is 1.81.
1 minus 0.67. 2.
So
Yes, sir. 1.817.
okay, now these values are impedance affected. These values you have got with respect to high voltage side.
Yeah,
Okay.
yeah.
Now in the question it is asked, find the leakage impedance and effective resistance and refer to low voltage side. What you will do for low voltage side?
Just we will divide it by a square, sir.
A square. So A value is 10.
0.37.
A value is 10 because
Okay, okay.
2
Okay.
point it is given as NHV by NLV is 2400 upon 240, that is equals to 10.
Yeah.
So this is, I told you, with when it is with respect to high voltage side, values are definitely going to be high. When you refer to low voltage side, the impedance value and the resistance or the reactance value has to come down. What will you do? You will divide R low voltage will be equal to
0.
1.4191 divided by 10 ka square. Similarly, Z x equal to 1 XLV is equals to 1.81 upon 10 square. So you will get something, the answer is in the divide by 100. So
Yes,
you
sir.
will get
0.01.
hmm. It will be in terms of millivolts, 14.26 plus J 18.14 milliohm.
Yes, sir.
Okay. So I'm going to conclude now. Next lectures we will be seeing other
Sir,
parts.
is there are more questions, sir, or not?
Yes, I have more questions, but I'll
On this
stop.
on this pattern, sir, for this session.